I can beat the system, but you can't. I mean, even the movie Casino, there's a great scene in there about Gambler's Ruin, remember? The Japanese guy, the Japanese business guy? In Casino, there was one minor... Everybody seen the movie Casino? With De Niro and... There's that scene where the Japanese businessman is winning. I think he's playing poker. I think it's poker. I could be wrong. But he's cleaning up and he tries to leave. And De Niro makes up the story. Oh, you're playing...
They give him more credit.
Yeah, they give him more time.
They give him more time and credits. They take the best room in the hotel. Here's some more coins. Keep playing.
Yeah,
because eventually you can't escape the probability. The probability is you will lose. You might win in the short run, yes? Remember all those little quick little boxcar blurps we saw? Sure, in the short run, but in the long run you're going to lose. So if you keep playing, basically guaranteed income. More on that next time. I had 3 experiments planned, or 4 experiments planned for today. We got through 2. That's totally fine. I love the fact that you guys are asking all these questions about the makeup of these distributions. But I want to show you how this applies to things like life insurance, how it applies more to Vegas. We'll start with the Vegas example next time and go into life insurance, and then go into my chicken flock again. Not egg production, but when you go to buy chicken. Anybody going to buy chicken soon? Soon. We're getting the chicks are coming soon. Next couple of weeks. This weekend. When you go into the store, well, we'll get to it Thursday. Analyze probability of chickens.
Last time I got 3 roosters.
You got 3 roosters. How many total did you buy?
I think 25.
That does not surprise me at all.
We did 30 and we only got 1 rooster.
Boom! That surprises me a little bit more, actually, believe it or not. That surprises me more than that surprises me.
We got 8, you got like 4 roosters.
8? That surprises the hell out of me.
That's crazy.
Based on, now, and I want to talk about why that surprises me probably more than Lauren's, which surprises me more than Danielle's. And there's a reason for all of that. It's based on these distributions, believe it or not. It's all based on this. It's rolling a die when you go to buy a chick. It's rolling a die. It's a girl or it's a boy. They tell you it's a girl, they tell you it's sexed. And it has been sexed, but the sexing process is not perfect. Based on that percentage that they give you at the store, you can actually figure out how surprised you should be for all those results. So that's what I want to get to next time too as well. So it's amazing how many places of your life this idea can kind of reach out into. Good. Let's start with the Gambler's Ruin though. Go ahead.
I had 5 1 flips and I got heads.
That's okay. Hold that thought. That's good. So 5 out of the 10 you got 1 flip. No, that's average.
Oh, that is.
That's actually perfectly average. Corbin, go ahead.
I got 5 heads in a row.
That is a little bit more. It's a blurb in the long stream, yes?
Okay.
But definitely expect it over the long run.
Took me 22 to get to 10.
There.
Total.
Awesome. Hold that thought. What I want to do is let's collect this data. I want you to see how this is similar and also different than the dice data you guys just collected, okay? So X, we're going to go X is the number of flips. So number of flips it takes for us to get heads. What's the smallest value on that?
10.
1.
1, right?
Oh, 1.
Well, we're going to break you guys down into 10 different groups, so 1 is the smallest. I obviously 10 if you're getting 10 heads. But the reason I had you do 10 is because we're 25 or 30 of us. I wanted to make sure we generate enough data. So obviously 1 is the least number. If you flip heads, boom, you're done. It might take 2, it might take 3, it might take 4. When can I stop writing?
Keep going. Keep going. There you go for me.
So, but technically, can I stop there? Couldn't it take 10 or 11? Oh, we got a 10?
No.
We didn't have 10. Did anybody take more than 10 flips to get their heads, or was 9 the largest we got? Technically speaking, shouldn't it go off to infinity?
Mm-hmm.
That's an interestingness. This is different than a set of dice. A set of dice is capped out at 12, or whatever the sum of the 2 largest numbers are on the dice. This technically goes off to infinity. I mean, theoretically speaking, you could roll or flip tails infinite number of times. It's the infinite monkeys. That's Shakespeare. You could get. I was like, I don't buy this infinite monkeys thing, and I'm sorry. Sorry, Stephen King novels with the damn monkey and the symbols. But theoretically speaking, it exists. Now, realistically speaking, it's probably not going to happen. Which is why we can stop at the 9. Because Richie got 9. Everybody else got more than 9. Love it. I'm going to put a frequency collection column in here. Right, before we go straight to probability, let's go to frequency, which is how many times it took us 1 flip to get heads. So I know a couple of you got 5, yes? Let's raise hands, show me with fingers how many times it took us exactly 1 flip to get heads.
On the first one?
Yeah, so basically you flipped, got heads, and you wrote down a 1. How many 1s do you have? Let me see, and you might take 2 hands. For a bunch of us it does. For quite a few of us it takes 5. I wish I had a snapshot of this. I could graph these results too. It'd be kind of cool to see the bell curve around it. But let's see if I can count now. not guaranteed. 10, 17, 20, 3, there we go, 23, 27, 32, 41, 48, 52, 54, plus 9 is 63, 65, 72, 76, 81, 84, 95. Thank you. 95. Beautiful. Beautiful. I'm going to hypothesize about 200 total trials in this room. I don't know. I didn't count you guys when you came in here today. How about two flips? How many times did it take you two flips? So you went tails, heads. So you won back your dollar, but it cost you $3 to win a dollar. Right. I'm sensing this quiz for next. This will be fun. Fun quiz for next week for you guys. Maybe. You might hate it. In which case, you just don't do it. Why did I come to this class today? All right. 2, 4, 9, 11, 13, 15, 18, 21, 24, 25, 29, 31, 39, 43, 45. Okay. Beautiful. 3 flips. 3 flips. How many times did it take us 3? Tails, tails, heads. So now you spend $7 to win a buck. $7 to win a buck. Yeah. 1, 4, 5, 8, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 22, 25, plus 9 is 34, 36, 37, 38, 42. How about 4? How about 4 flips? 4 flips. So tails, 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 heads. 3 tails followed by heads. 1, 2, 3. 8. Pretty cool. That happened to you 5 times. That's freaking rad. 8, 10, 11, 12. 12. What are you noticing as we go down the line?
Less and less.
We're decreasing. Does that make sense intuitively?
Mm-hmm.
Can you change 95 to 93?
Of course I can. Not a problem. This is why I like collecting a whole bunch of data. Inevitably, I'm going to screw up adding. We'll see this in a minute when we add up this entire column and see what it adds up to. No, but I blame it on me, because usually I screw up anyway. 5! Tails, 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 tails! Heads. 1, 2, 3. 6! 1, 2. 7! 8! 1. 9. 1. All right, add them up. Let's see how close I got. Should be some multiple of 10. Guaranteed it's not because it's me.
Add 1 to 6.
Add 1 to 6. So that should be a 3. There we go. 5.
It's 93.
20. 62. 107. Holy sh.
Whoa.
20 years of teaching, that has never worked. Blind squirrel gets nuts sometimes. Shakespeare's and his monkeys. I love it. Beautiful. 200. I probably had it wrong.
I had it right. That was over.
200.
Oh my God. Yeah.
Freaking damn. That's fantastic. The reason I get so excited about this is the next part is very easy to do now if that's correct. Thank God. So here's what I want you to do next. I want you to calculate. I don't want to actually use this column for any computational purposes. I mean, we could.
21 people in there.
There's 21 people in the room. Shh. Did you count me?
No.
Shit. Only off by 10. There's a 10% chance of that happening. It's all good. Thanks, Austin, for pissing on my parade. Well done, sir. Well done. Now you can totally run one var stats on this. You can totally run one var stats on this. Absolutely, absolutely. But let's not, because this is going to treat this as a sample. Yes, it's going to treat it as a sample. So what I'd like you guys to do right now is we're going to create a phrase temporarily, and then we're going to create a second column that's more rigorous called the probability column. So we're going to get around to making our distribution. But what I want to do right now is create what's called a relative frequency. Now, you might remember this from a couple weeks ago. You probably don't, and that's okay. All that means is percentage of occurrence in your sample. So in other words, we saw 93 once out of 200, yes? 93 out of 200. As a percentage, I think that is going to be 41.5, thank you, 41.5%, right? 41.5%. Now the way you can do that is just divide that by that. That makes sense? So do that for each of them. Let's see if we can do this. This should be 22.5%, I think. Check my math on this. I'm not to be trusted. 21%, 6%, 1.5%, again 1.5%, 1.5%, 0.05, 0.05. And that should add to 100%, assuming I did the division right, and assuming, is that fair? Ish?
Does it?
I don't know, it should if I did the math right, let's see.
That's right. Yep. Oh, yeah.
64, that's 64%. 85, 91, plus 3 is 90, no, it doesn't.
Yeah.
It's,
Wait, hang on a second, what did I do wrong? I did something wrong on my head.
the top one is 465.
Oh, it's 46.5!
46.5.
Feed me bad numbers, Rory.
My bad numbers.
I should have caught it too, though. 46.5%, thank you. And that explains the percentage we were off by. Beautiful, thank you. Whew. Thank you guys for spot checking my work and Rory's work. I'm gonna blame myself though, as Austin pointed out before. All right, good. Now, for starters, we now have a probability distribution based on historical data. Now, I'm calling it historical. It's hardly historical, it's 200 trials. It's 200 trials. But sometimes, this is all you can get from a statistical study, just like say 200 trials. Sometimes you can't even get that. So based on that, can you guys run this through L1 and L2 and get me an experimental average? Yes? Let's do it. Let's do it. Then we're